The James Webb Space Telescope is a space telescope designed primarily to conduct infrared astronomy. As the largest optical telescope in space, its greatly improved infrared resolution and sensitivity allow it to view objects too early, distant, or faint for the Hubble Space Telescope. This is expected to enable a broad range of investigations across the fields of astronomy and cosmology, such as observation of the first stars and the formation of the first galaxies, and detailed atmospheric characterization of potentially habitable exoplanets. The U.S. National Aeronautics and Space Administration (NASA) led James Webb Space Telescope's development in collaboration with the European Space Agency and the Canadian Space Agency. The NASA Goddard Space Flight Center in Maryland managed telescope development. The Space Telescope Science Institute in Baltimore on the Homewood campus of Johns Hopkins University operates James Webb Space Telescope, and the prime contractor was Northrop Grumman. The telescope is named after James E. Webb, who was the administrator of NASA from 1961 to 1968 during the Mercury, Gemini, and Apollo programs. The James Webb Space Telescope was launched on the 25th of December 2021 on an Ariane 5 rocket from Kourou, French Guiana, and arrived at the Sun-Earth L2 Lagrange point in January 2022. The first image from JWST was released to the public via a press conference on the 11th of July 2022. The telescope is the successor of the Hubble as NASA's flagship mission in astrophysics. James Webb Space Telescope's primary mirror consists of 18 hexagonal mirror segments made of gold-plated beryllium, which combined create a 6.5-meter diameter mirror, compared with Hubble's 2.4 meters. This gives James Webb Space Telescope a light collecting area of about 25 square meters, about 6 times that of Hubble. Unlike Hubble, which observes in the near ultraviolet and visible that is 0.1 to 0.8 micrometers, and near infrared which is 0.8 to 2.5 micrometers spectra, James Webb Space Telescope observes in a lower frequency range, from long wavelength visible light through mid-infrared that is 0.6 to 28.3 micrometers. The telescope must be kept extremely cold, below 50 K, such that the infrared light emitted by the telescope itself does not interfere with the collected light. It is deployed in a solar orbit near the Sun-Earth L2 Lagrange point, about 1.5 million kilometers from Earth, where its 5-layer sun shield protects it from warming by the Sun, Earth, and Moon. Initial designs for the telescope, then named the Next Generation Space Telescope, began in 1996. 2 concept studies were commissioned in 1999 for a potential launch in 2007 and a $1 billion United States budget. The program was plagued with enormous cost overruns and delays. A major redesign in 2005 led to the current approach, with construction completed in 2016 at a total cost of $10 billion United States. The high-stakes nature of the launch and the telescope's complexity was remarked upon by the media,